Hey guys, a little video here to go over the rest of 3E. Hopefully, we got a pretty good grip on this stuff, but in case you haven't been here, I just want to do this to help you guys get wrapped up and caught up if you need to. So, I'm going to start here on number 5 here on the second page with this objective function 2x plus 5y. And we have these constraints. X is less than or equal to 5, y is greater than or equal to 3. Negative 3x plus 5y is less than or equal to 30. Okay, with our constraint functions, we need to get the variable by itself. So these two are already good. We have negative 3x plus 5y is less than or equal to 30. So in order to get the y by itself, we'll add 3x to both sides. Add 3x to those sides. That goes away. And then we can divide by 5 and divide by 5. So our third constraint function is going to be y is less than or equal to 30 plus 3x over 5. Again, with these constraints, x is less than 5, y is greater than or equal to 3. So we can go into our calculator here where we have x equals 5, y equals 3, and then 30 plus 3x over 5. There. All right, so got to get this problem back. So x is less than or equal to 5, so x is less than or equal to 5 here. And then we have y is greater than or equal to 3, so we're going to be up here. And then we're going to be underneath this black line right here. So what's going to happen is our 3 points are going to be here, here, and here. Find those points just by taking our thing and clicking. So we got 5, 9, 5, 3, negative 5, 3. So 5, 9, 5, 3, negative 5, 3.
Good morning, staff and students.
Okay, back at it. So we have our 3 points, 5, 9, 5, 3, negative 5, 3. So we'll plug all those back into our objective function. So we'll have 2 times 5 plus 5 times 9. Then we'll have 2 times 5 plus 5 times 3. And then we'll have 2 times negative 5 plus 5 times 3. And we'll equal those out and then get our maxes or mins from there. All right, moving on. I want to skip through a few of these here. Numbers 4 and 5, I think I told y'all to not do, so we won't do them there. If you have a question, we could talk about them individually. 1 and 2, we did in class yesterday, and so I would like to do number 2 real quick just to make sure we're good. That one's a little bit harder. So first thing, we have to get y by itself and all these things here. So we have the 3x minus y is less than or equal to 7. A couple of ways we can get y by itself. We could move the 3x and divide and then switch the sign. So we can minus 3x and minus 3x. So now we have negative y is less than or equal to 7 minus 3x. Now just recall, when we divide or multiply by a negative, we got to flip this sign. So when we divide by negative 1, really we're going to have is y is greater than or equal to 7 minus 3x all over negative 1. All right, so that'll be that first function right there. The next function, we have 2x. 2x minus y is greater than or equal to 3. Okay, again, we'll minus 2x and divide by negative 1. So what we'll have is we're going to have y is less than or equal to 3 minus 2x all over negative 1. In our third function, we already have y by itself. We have y is greater than or equal to x minus 3. All right, so coming back over here, we've got 7 minus 3x over negative 1. Whoops. And then we have 3 minus 2x over negative 1. And then our last one is y is greater than x minus 3. All right, so we're going to have this thing here when we graph our inequalities. When we graph our inequalities, we're going to have a point here. Let's clear this screen up for a minute. So we're going to have a point here, here, and up there. And so we get these 3 points. We got 4, 5, 2, negative 1, 0, negative 3. 4, 5, 2, negative 1, 0, negative 3. Pause the video if you need to while I go back to the thing. So we have our objective function here. 4, 5 could be one of our points with our objective function, x minus 4y. So we'll have 4 minus 4 times 5. Another point was 2, negative 1. So we'll go 2 minus 4 times negative 1. And the last point was 0, negative 3. So 0 minus 4 times negative 3. So 4, 5, 2, negative 1, 0, negative 3. Plug those in to our objective function, get our 3 numbers, and then determine what the max is. Okay. All right. Word problem here. I'm just going to get the word problem set up for you guys. A glass blower can form 8 simple vases or 2 elaborate vases in an hour. In a shift of no more than 8 hours, it must form at least 40 vases. S is going to represent the hours of simple vases. I'm going to change that to X. E, the hours elaborate vases, so Y. There. So X and Y are going to be the number of hours that we work. All right, a little bit of a confusing thing, so we can still sort of work with this though. So in a work shift of no more than 8 hours, which means X plus Y, our total number of hours is going to be less than or equal to 8. All right, for our second equation, we have 8 simple vases in an hour, 2 elaborate vases in an hour, and we got to do 40 vases total. So our second equation, or at least 40 vases, so 8x plus 2y is going to be greater than or equal to 40. All right, so those are going to be our 2 constraint functions right there. These are going to be our constraints. All right, so A is just asking for our constraint function. So $30 per hour on a simple vase, $35 per hour on an elaborate vase. Write a function for total profit on the vases. So that's going to be our objective function right there, which is going to be 30x plus 35y. Find the number of hours a worker should spend on each type of vase to maximize the profit. What is that profit? Again, what we're going to have to do is we're going to have to graph our 2 constraints. All right, so our 1 constraint function is going to kind of look like that, where we're here and we're shading underneath. All right, and the other one we're going to be sort of here. 8x plus 2y, actually, that's not going to be right. Try to do this all from my memory here. So the y-intercept is going to be up there at 20, and the x-intercept is going to be here at 5. I'm just sketching this freehand. And now this one, the y is going to be greater, so what's going to happen is the blue is going to shade over here. So our constraint area is actually going to be sort of this little triangle right here, because we're going to be below the red but above the blue. So we're going to have sort of 3 corner points right there in order to find that profit. Okay. This one, functions are already set up, so I'm going to skip this manufacturing one right here. This is a really hard one on the very last page that I want to talk about, and that's the farm stand sales, okay? So when these functions are written with a lot of stuff, the best thing to do is go back and look at our objective function first. All right. Our objective function is profit. So $2 profit on every jar of tomato sauce, $1.50 profit on jar of salsa. So our objective function is going to be $2 for a jar of tomato sauce, which we'll call X, and $1.50 Y is our objective function. So X is going to be tomato sauce, and Y is going to be salsa. Again, a lot of stuff in these equations, and so because we have a lot of stuff in these equations, sometimes we need to go back to the objective function first to find what our variables are, okay? So our variables is going to be jars of tomato sauce and jars of salsa. All right. All right, so then this is where we're going to go back and sort of and figure all this out. All right, so since we have tomato sauce and salsa as our 2 variables, tomato sauce and salsa as our 2 variables, both of our constraint functions are going to have something x plus something y is, equal to something, or greater than or equal to or less than or equal to something here. Okay, so we have tomato sauce and salsa since are our 2 variables right there. And the things that are being input into these things are tomatoes and onions, okay? Now, one thing that we cannot do, since tomato sauce and salsa are our 2 variables, those are the only things that can be different in each equation. So the equations need to sort of have the same, we need to be working from within the same system. So whether it be quantity or money or hours, we sort of need to be working within the same kind of unit, okay? Same kind of input, if you will. So tomatoes and onions are the inputs. So what we're going to have to do is we're going to make our first equation with tomatoes, okay? Now, we have 180 total tomatoes. So that'll be over here. So a jar of tomato sauce requires 10 tomatoes, okay? So 10 tomatoes per jar of tomato sauce. A jar of salsa requires 5 tomatoes. So 5 tomatoes for a jar of salsa. Add those up is going to add up to 180. Okay, so we have 180 total tomatoes. So if there's 10 tomatoes per jar of tomato sauce plus 5 tomatoes per jar of salsa, it has to add up to be less than or equal to 180. Okay, so our first equation is going to be sort of in tomatoes. Our second equation, now let's work with onions, because that's what our other thing is. Again, we cannot put onions and tomatoes sort of within the same equation because they're 2 different kind of units, okay? We have 15 total onions left over, and so we'll go from there. So a jar of tomato sauce is 10 tomatoes and 1 onion. So 1 onion for a jar of tomato sauce. A jar of salsa is 1/4 of an onion. So here is what our constraint functions are going to be on this farm stand sales right here. Kind of a complicated problem, but again, what we need to do sometimes, and we saw this on today's warm-up, is go back to the objective function, see what the objective function is and what units we need for our variables. And once that picture is kind of cleaned up, that we know what our variables are, then we can kind of work with what kind of inputs that we have for each variable and what kind of equations that we need to write given the information that we have. So that's how this would look. And then you can go ahead and solve all that right from there. If you have any other questions on the rest of these notes, please let me know. I just wanted to give you kind of what you needed, sort of the bare minimum of what you needed to be able to get through all these. But on an as needed basis, we can look at more of these if you need to. So you guys take care and have a good weekend.